Here's my solution to the first problem in assignment 2. So the problem gives us the angular speeds of pulley A connected to pulley D, which is directly linked to pulley B, and connected to pulley C via belt. So when t equals 3 seconds, what is the angular speeds of all the pulleys? So right off the bat, I drew a little diagram over here visualizing everything that's going on and listed all the different radii corresponding to their points and all the other information that I wrote above, such as what we need to find. So we need to find omega B, omega C, and omega D. So then I wrote our assumptions. So we must assume that the belt has no slip condition and the belt is unstretchable. So that means that the length doesn't change over time via stretching. So we can also determine that omega B is equal to omega D because they're literally connected. So their speeds are going to be the same thing. So first I'll find omega D. That's going to be done. So going from A to D, that's going to be the speed of A equals the speed of D. So that's RA omega A equals RD omega D. So then I just isolate for omega D, plug everything in with the equation before time is involved, and I get omega D as an equation. Then omega D at 3 seconds becomes 300 rads per second. So then I use this information to go from B to C. So the speed of B equals the speed of C, and I use the same formula, same rearranging, and I use omega D equals to 300 rads per second as omega B since they're the same, and I get omega C equals to 600 rads per second. So that means that the angular velocities for all the components are omega A equals 100 rads per second, omega B equals to omega D, which equals to 300 rads per second, and omega C equals to 600 rads per second at t equals 3 seconds. That is my solution.